Hello, everyone, and welcome to the second Q&A session of the day. My name is Andrey Golovanov. I am from the Backbone team at Meta. I'm very happy to be here with you moderating this session today. Together with me, we have Steve and Joseph from Meta and Somesh from Microsoft. Truly amazing innovation at scale in both the talks. So there are lots of topic for discussions. So let's jump right into it then. And we will go sequentially step by step through the speakers to make it simpler for the audience. Then, Steve, let's start with you and with a quick warm-up. One question that has been bothering me is, why did we go with aluminum into Africa? Isn't copper a better conductor that would yield smaller voltage drop?
That's an excellent question. Because yes, aluminum is only 61% the conductivity of copper, so it has less conductivity. However, it's 30% of the weight of copper and only 25% of the price of copper. So let's say, and what we do is we increase the amount of aluminum to get the same resistivity as copper in the cable. So you increase the amount, but then your cable is 50% lighter and it's about 60% cheaper. So that's what you're doing. You're compensating the amount of aluminum. So it does make sense from both a weight and price point of view in the end. But even beyond that, we will be able to add more aluminum beyond that to get it to conductivities below that of copper. Regions that would be inaccessible by copper from a pricing as well as a weight point of view, we could reach with aluminum. So that will lead to lower conductivities than ever before. Since about 50% of the power in a subsea cable is lost due to ohmic losses in the cable, this makes sense. We can make a much more efficient cable in the long run. So yes, aluminum makes sense in the near term and the long term, in spite of being less conductivity.
Thank you, Steve. That's amazing. This brings me to a wider question on innovations then. So is there a limit for how long we can continue this exponential growth? Like technology, power, people?
Yes. So it's hard, actually. So I can see perhaps the next 10 years. Beyond that, it's difficult. You know, I've actually talked about in the industry something called Neptune's Law, which is kind of the law of subsea capacity. And it's a techno-economic law, and it's kind of similar to Moore's law in several respects. So I think we can only see the technology 5 to 10 years out. And beyond that, you know, it doesn't, we don't have visibility of how to continue that curve. But when you go back and examine Moore's law, it was very similar. People throughout every point in time kind of had limited visibility, and they said, okay, we're done in 5 years. They've been saying, we're going to reach the limit of 5 years. They've been saying that for the last 25 years. And so it's amazing how innovation seems to continue. You know, again, it's a techno-economic thing. First of all, you have to have the need for that capacity. And also it has to be economic. And we're also working on the price per terabit of the capacity. But yes, it's always challenging, these techno-economic laws, to realize how to keep up. But in the end, if the needs and demands are there, somehow we always find a way.
That makes total sense. Thank you, Steve. Yeah, I'm sorry for my light going out. I'm in Dublin, and the office isn't light-saving mode. So I'll be reaching out to the right and enabling the
saving power.
Yep, saving power, exactly. Right, so we just mentioned the years. And speaking of the years, one thing struck me. In the talk, you mentioned that there is 4-6 years build time for each project. Why is it taking so long?
Well, it takes so long for several reasons. first of all, you have to do a complete survey of the ocean floor. The ocean floor is there are more topological features more than the mountain ranges on Earth, right? We have the Marianas Trench, you have huge trenches, underwater volcanoes. You have to do a complete survey to make sure it's a suitable route for laying the fiber. Plus, you have to apply for all kinds of permits, in both continents that you're originating from and landing in. So the combination of the survey, the permits, and just the massive scale of these projects leads to a 4 to 6 year time frame.
Makes sense, Steve. Yeah, thank you. And speaking of speeding up the builds, can we leverage some innovations like unmanned submersibles or vehicles?
Yes, yeah, that's a great question. So actually, we do have the industry has a conference coming up called Suboptic in the spring, and it's held once every 3 years for this industry. And yes, we'll have presented some talks on unmanned survey vehicles. There's a company called Saildrone, which I've actually seen on the news, CNBC recently, where they have unmanned autonomous vehicles that go out into the ocean and can survey. So it's a very green technology, so, it's kind of a waste to send out an ocean liner with all of these people on board to do a survey. That's the way it's done now. So if we can do an unmanned vehicle to do that work and use much less energy, a green solution, that's all the better. So we're all working on that, and perhaps in a few years, we will see that come online.
Thank you, Steve. Then a more broad question. So we heard that the subsea industry is fairly conservative. What is your take on it? Is the industry changing fast enough to keep up with our growth?
Well, we're making great strides, but of course, we're never satisfied at any given point in time. Things always move slower than we all desire. But I would say overall, we are building enough systems along with our partners. Such I mentioned, we partner with Google and Amazon on certain of these systems. We build them together, and I think we have enough collective purchasing power such that we're given a big voice in the industry, and I think we're starting to change things significantly.
Yeah, really hope so. Thank you, Steve. Yeah, that's great. Thank you for your answers and insights into the industry.
Thank you.
Now over to you, Joseph. Yeah, it's an amazing challenge to manage such a huge network infrastructure, I bet. And one thing that made me curious, so you mentioned that you use text parsing, like CLI text parsing, to retrieve data from network devices. Why do we do that? Why don't we instead switch to something structured and maybe open, like open config, for example?
Sure. Thanks, Andrey. And yes, I think it's kind of amazing what we're able to do operating a network, and all credit to the rest of our team. We're fairly small compared to our peers, but we're still successful being able to operate. Now, part of the reason we've been able to do this is that we're a production engineering organization, and ultimately that means our day job is focusing on trade-offs. Get the most bang for your buck with the resources that you have available. Now, when it comes to our network operations, we actually do more than just CLI parsing. We support everything from TL1 all the way up to some structured configs like netconf. But we're able to scale by having a very close working relationship with our vendors. In slight contrast to the IP world, while we do try and embrace openness, the fact that the optical network is scaled geographically means that things are distributed. And so we typically tend to have one or two control systems operational at any point in time, and not more than that. Now, what that means is that if you do need to make changes, you do need to rely on a very close relationship with your vendor to ensure that these changes get into production really, really quickly. Ultimately, we have done this successfully to bring on board, some of these other protocols, the structured ones. But every engineer knows at some point you will need to use a CLI. You could have a bug that means you simply kind of log into a box. And so, netconf is great, but hey, you need to log into the box to actually use it. And so, CLI passing does give us ultimate flexibility, and gives us a really quick turnaround in terms of building new production tools. But I'd like to take away the fact that we do support everything. CLI passing is really just a fraction of all the automation that we build. But we're protocol agnostic, and without that, we wouldn't be able to scale in the way that we've done so far.
Thank you, Joseph. Makes total sense. In the talk, you mentioned the term migrations several times. So what exactly does that mean in the context of the optical network?
Sure, thanks. One of the nice things about this session today is I wasn't the only person to talk about migrations. Previous speakers mentioned them in the case of data center networks. And that's, standard term for anyone dealing with, layer 1 or maybe layer 2. So migrations are fundamentally network operations that involve capacity moving from one set of physical infrastructure to another set. Generally, these sets of operations involve some physical change somewhere, at least for simplicity. For example, we might be moving capacity from one data center building to another as part of the natural evolution of the data center. Within the optical domain, one of the challenges that we have that is fairly unique to optical is the fact that everything is bookended. You have to schedule operations across both ends of your network. And in certain cases, for example, if you're making changes to a site through which capacity transits from 4, 5, 6 data centers on both ends, you're actually ultimately affecting capacity going across squared site pairs. So in the optical domain, migrations are very carefully planned and scheduled activities that involve, as I said, bringing IP capacity down. And one of the big challenges for us is we do have to schedule these things simultaneously across the network without introducing risk. So without bringing capacity below a critical level required to sustain the network in the event of unplanned failures. We've been able to do this thanks to our investment in building a topology that gives us an up-to-date view of the network currently, as well as the potential state of the network in the case of potential failures. We work very closely with partners, both in the IP space, as well as the network planning org, who are predictive models that predict the risk that comes in from network changes. And finally, we work fairly closely with deployment teams to make sure that things happen on time and automation failures can help kick in case migration is happening and something happens that causes us to need to revert it.
Thank you, Joseph. Yeah, so that's a comprehensive cross-layer activity that is pretty much impossible to get done safely without vast automation, right?
Yes.
Awesome. Yeah, thank you. Thank you very much for your answers, Joseph. And now let's switch to the next topic. So Somesh, now it's over to you. And you can imagine my vast interest in the topic, given that I am from the Express Backbone team at Meta. So lots of questions, lots of discussion points. And the first up is, it seems that the merge of the classic backbone and Swan makes controller resilience even more important. So how do you address the risk of global controller outages?
Thanks, Andrey. And this is a very good question. So I think the biggest risk we have is about the global controller outage. So what we have done is we have a thing called blast shield. What we have is for every geography, we have a separate set of controller operating today. And each of those controllers takes the deployment of it, the safe deployment practices followed to make sure that the no two controllers are basically kind of getting impacted by the same bug if it's during the change and something like that. And they operate completely independently. Now, most of our traffic is within the continent as well. And we have lot of traffic in the cross geo as well. But I think if you look at it, an amount of the WAN traffic within the continent, so them operating within the continent and having their own individual view of the continent has helped us to kind of design the blast shield in a way that we can avoid this global control outage. And there's no way to avoid kind of global control outage by having separate instances of each and every controller operating independently and the safe deployment practice. I think the blast shield is the answer for us to avoid the global controller outage.
Thank you. Thank you, Somesh. And then speaking of the controllers, so you mentioned another controller in your talk, the controller for internet traffic engineering. So how does that controller interact with one WAN traffic engineering system?
Okay. So if you look at it, the internet traffic engineering system is operating to remediate the issues which is happening on the peering network. And most of the issues can happen that we don't have capacity or the peer has some issues on their router. We can actually detect that as well. However, when we have to go, let's say if we have to go cross site to a different location, then we also have to look at it. What is our backbone capacity to carry the traffic to the next site where we're going to migrate the traffic to? And that's when the internet traffic engineering systems calls the one-way traffic engineering system to check that do we have this site has the backbone capacity to carry that traffic from one site to the another site. And then if the one-way traffic engineering system says that, hey, I don't have the capacity, I have to reroute on a longer latency path, then it can give other options to the site. And usually for given internet peer, given the scale of the Microsoft network and the connectivity we have multiple options within the latency bucket of when we want to traffic engineer certain internet traffic. And that time we can choose between few of the sites, and basically it can also have the intelligence to divide the traffic between those two sites. Given the prefixes, it can calculate and say, hey, if you do not have, let's say, 100 gig of backbone capacity, can you take 50 gig of it and then do, and I'm just talking in terms of the relative numbers here. They can basically divide this thing and operate that way. And then the backbone will say, okay, I will deliver the traffic to this router, and then you can deliver to the peer. But if you have to do within the site itself, like we have a same peer or different peer which can handle this traffic, then we basically can operate independently without notifying the one-way traffic engineering system.
Makes sense, Somesh. Yeah, thank you. Yeah, that's quite important to architect these two rights to prevent possible oscillations. Right. Yeah, okay. So then, speaking of the challenges, in the talk, you touched upon a few challenges on the path to one WAN. And among them were routing scale and the number of nodes. So how did you address these challenges in your architecture?
So most of the challenges, they're always going to be there. As we scale the network, the challenges get to the next level. However, I think one fundamental approach we have taken to scale our network is to partition it. And the way we kind of partition it, we have layered partition now. So we have, as you talked about it, we have geo partition. On top of that, underneath that, we also have some region partitions as well. So there's some, like for example, in North America, you can have 6 partitions to address the Northwest, South, East, and so on and so forth, because we have to have kind of a layered architecture in order to scale this network. Because every time the data center team is going out and expanding the regions, they're just adding the nodes. And we need to add the number of devices in order to scale. And, it's basically the challenge never gets solved. But it's just that we have to keep on adding kind of what we've taken is a layered architecture. Like every time we're going to exhaust a particular layer, we're going to think about it, creating a sub-layer in order to not have this layer take on the entire work of dealing with the route scale and everything. And the network design is in such a way that the router which needs to know the route for functioning, the entire thing should only have that many routes. It should not have like all the internet routing tables sitting in it or all the entire information sitting in it. Not many copies and scale rib and fib data should be to that router what it needs to be there. But it's about the the layered architecture, I think we slowly kind of, we build, let's say, we had started with one global controller. Then we have the blast shield done to have the geo partition. Now we're looking at the next layer architecture is our region partition, where basically we can go further more because we're just adding nodes and scaling up the network every day. So this problem never goes away, but it's like you have to think about it, like keep adding the layers as a fundamental way to partition the data.
Thank you, Somesh. So yeah, it seems the sharding, like different types of sharding, is kind of the answer to many problems. Thank you. Right, and then possibly the last question. Again, about the challenges. So how do you approach vendor diversity in this large-scale network?
So I think few years ago, we didn't have much vendor diversity to begin with. As there are certain hardware vendors who kind of produce the devices which can operate at the WAN layer. However, as we are rolling out the one WAN, for every role, we have 2 vendors now. For every role in Microsoft network, wide area network devices, for example, the routers which connects to data center, we have 2 vendors, if not more. Every role we have looked at it. And then, of course, one of them will basically be our own operating system, which is the Sonic, which is the open source operating system. So think about it. If you have 4 devices, you will have 2 vendors operating 2 devices, and one of them will run Sonic on the each side. So we're kind of looking at it that way to do this kind of network. Right now, we have not like basically kind of deployed the Sonic everywhere, but at least on the vendor diversity, we have, for every role, we have 2 vendors coming in as look at the number of devices, because minimum devices you will have it is 2 or 4 or 8 or 16, but I think looking at 2, even 2, we will have 2 vendors coming in, and we always do that way because we have been in the past has been hit by this kind of issues where some kind of security vulnerability can impact the entire fleet at some point of time. So yeah, that's been our approach for the last 2 years now.
Yeah, that's an amazing challenge to get solved. Yeah,
yes.
Thanks a lot. All right, I'd love to continue this discussion, but unfortunately the time is to wrap up. So thanks to everyone, to all our speakers and everyone who joined this session. Thank you and goodbye.